Let's look at this example two. Example two actually follows the same circuit from example one, but it asks you to compute the power. The power here means if it doesn't specify what kind of power, it means true power. And also reactive power taken from the source. Also, compute the power and reactive power delivered to each element. Okay. In this case, to calculate the power, the easiest way is we resort to complex power. So if we calculate complex power, please go back to the notes. So complex power is actually defined by 1 over 2 V uh, times I star. Okay. So, for this, if you remember, um, yeah, let me write it here. Let me write it here. So the complex power can be defined by, as a reminder, the complex power can be defined by 1 over 2 V times I star. And if we convert a Z into R plus JX, and then we also find out IMS. We also find out, so this is V, this is I. Okay, let me draw this. So if this is V, and so this is R plus JX, and this is I. And then, so the complex power can be written by I RMS square times Z, okay, which is I RMS square R plus J I RMS square X, or we can say it is 1 over 2 I square R M. IM square R, the amplitude of current square R plus J 1 over 2 IN square X. Okay, so that's the easiest way to calculate this true power, reactive power from the source by this formula. If you don't know how to derive, and if you have any doubts on this regarding this formula, please go back to our notes. Okay, so we need a few things from example one. First, we need the total impedance, and we need this. We need I and have total impedance. So oh, actually, I just need I and total impedance. So I is, so let's go back to example one to look at I. So I is amplitude is 0.1414 and degree is minus 135. So I equals 0.1414 and degree is minus 135 degree. And second thing is we need what? We need Z. We need Z total. we need total impedance. So we have Z total is, we have total impedance here. The total impedance is 50 times square root 2, angle is 45 degree. So we have 50 times square root of 2, angle is 45 degree. So in the end, the unit is ohm. So since we are calculating the true power and reactive power from the source, so we can directly write this S equals 1 over 2. I just use the formula here. In the amplitude of current, which is 0.1414 times R. Okay, because we need R and X, so we need to find out this. We need to convert the polar form of the total impedance into rectangular form. So it is actually 50 plus 50J ohm. Okay, so we have this is R, this is X. So we have this times 50 plus J 1 over 2, 0.1414 plus 50. So it is actually what? Wait. So this is reactive power taken from the source. Okay, so all right. So which is 0.5. Let me double check. So we have 25 times 0.1414. Wait, wait, 0.1414. Oh, square. Yeah, I missed square. That's why there's something weird. So let me double check. So we have 25 times oh, square. Hmm, 0.5, which is 0.5 plus J 0.5. Okay, so the real part is true power. So we know the true power we have a symbol P equals 0.5. The unit is watts. Okay, as seen from the source. Okay, so we just use total impedance here. And the reactive power, we say it is Q, right? It's the imaginary part of this complex power, which is positive 0.5 VAR. The unit is voltage ampere reactive. Okay. And also compute the power and reactive power delivered to each element. Okay. So um, same thing, we apply this formula on the bottom right. So, but well, before that, we need to, because in example one, we already find out I, we already find out IR, and already find out IC. Okay, so the power and reactive power. So power delivered to R. Let me see if we have next page. Oh, no. So power delivered to R can be written as 1 over 2 I n R, right? Because resistor doesn't have imaginary part, so just a real number. So power delivered to R is uh, so I so oh R, let me write down IR. So this is so we need to find out IR. So power delivered to R, or we can say SE. No, it's better to say this way. Power delivered to R is IRMS square times ZR. Okay, and it equals 1 over 2 IN square ZR. Okay, and so let me check. IR is what? IR is actually, let's look at the previous page. IR is 0.1. We just need the amplitude. So IN here, IN 0.1. Okay, so equals 1 over 2 IN squared times R is 100 times R square 0.1 squared times 100, which is what? Which is this is 0.5 omega W, not omega W, 0.5 W. So we know it's true power, right? The power delivered to R to the resistor is just true power. Okay. And uh so the power delivered to the inductance is just let me say this is IR. It belongs to IR. So the power delivered to inductance actually because it's just reactive power. So let me say here, let me write it here. So reactive power. So how about I write it here? So I reactive power a little bit weird now. So deliver. Hopefully we can finish this problem soon. To inductor to L. Same thing here. S. But at this moment we need I. We need the amplitude of I, right? So IL. IM is at this moment 0.1414. This is from I. Okay, this is from I. And then we apply the this complex power formula. We have I RMS squared times ZL. Okay, which is however, ZL also only has an imaginary number, which is 100J. So which is J I RMS square. Uh, how about let's plug in a number. So we have IM, so it's 1 over 2 IM squared ZL, which is 1 over 2. It is 0.1414 squared times ZL is just 100J. So the answer should be the answer is 1, if I'm right. So let me double check. So 15 times. Yeah, the answer should be 1J. So it just has an imaginary part. So we know that it's a reactive power. So reactive power. So this is reactive power. So this is what? This is Q. So Q equals 1. And the unit is VAR. Okay, this is the reactive power delivered to the inductor. Same thing, we can calculate the reactive power delivered to the capacitor. So reactive power to C. Remember, inductors and capacitors, they don't consume power, so their true power is 0. They only have reactive power. Okay, so same thing here. S equals I. I just write the formula that we use directly. 1 over 2 IN square ZC, right? So right now the IN should be, we need to look at IC. So the amplitude of IC is 0.1. 0.1. This is the amplitude of IC. Okay, so we have 1 over 2, 0.1 square and times ZC. And ZC is, let's just look at the previous one. ZC is minus 100J. So it's minus 100J. So the answer is minus 0.5J. So it's Q. The power delivered to the capacitor is minus 0.5. The answer is voltage amp reactive. So we have, this is the answer. The power delivered to C. This is the reactive power delivered to an inductor, and this is the true power delivered to the resistor. Okay, and so this is the true power delivered taken from the source, and this is the reactive power uh, from the source. So we can also notice, let me use different color. You can notice that the true power delivered from the source is completely consumed by the power uh, delivered to the resistor. Okay, and the reactive power given by the source equals these two combined, right? So it's energy conservation. No matter it is a true power or reactive power, delivered from the source equals the true power and reactive power consumed by the load. Okay, this is the example number 2.